Alright, so today we are going to start section 2.2, but first I want you to try it. Think about this on your own, and using what you know, try to come up with these x and y values over here on the right for these three different angle measures. And to help you get started, here's what I would do personally. If I'm looking at the 60 degree, I would draw a line down here, a line across. If I put a little mark there, what type of triangle does that look like? Hopefully that looks like a right triangle. And then what you can do is that since that's the 60, since I know this is 0 and that's up to 60, that means this inside angle, this interior angle here is 60 degrees. So hopefully then that makes that hopefully you would be able to use your special right triangles to find your x coordinate and your y coordinate. And remember, that is x, that is y. So today we're talking about trig functions on the coordinate plane. So one thing we want to remember and want to think about is we've seen this SOHCAHTOA thing before. SOHCAHTOA. So we know that it was sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent side. Today, we're going to start talking about things in x, y, and r because, well, we're now on the coordinate plane. So instead of opposite sides and adjacent sides and hypotenuse, we have an x direction and a y direction. And if we're looking at that, here's a triangle drawn in standard form. Here's our angle measure. So if this is, we're always measuring what the angle that's on the vertex. One thing too is with these triangles, you should always draw the horizontal on the x-axis. Sometimes kids will want to draw it up here, and that is a big no-no. That's bad. So don't do that. That makes math really angry. So going back, this would normally be our adjacent side, right? That would be your adjacent side normally. This would then be your opposite. Oh, it's really hard to draw the mouse. And that would be your hypotenuse. There we go. So instead now, these are going to be defined differently. If we're just looking at this, that's our x. So this is now our x direction. That's now our y direction. And that's our radius r. Because if we were to trace all the way around the coordinate plane, that would make a circle. So the hypotenuse is referred to as r for that reason, for radius. So that leaves us with new definitions now. So sine, which was normally opposite over hypotenuse, is now y over r. Cosine is now x over r. And tangent would then be y over x. Alright, trig functions on the coordinate plane. So here's just some things you want to look at. We actually just covered these three on the previous slide. Now, there is something new here, however. And what you'll notice is the three below it. We have that, which is cosecant, secant, and cotangent. Now, think about it for a second. I want you to relate the two. If we're looking at these as columns, I want you to compare sine and cosecant, cosine, secant, tangent, cotangent. See if you notice any similarities, differences, etc. The next thing we want to look at, off to the side here, no, that isn't right well. Off to the side here, you'll notice, you see like y doesn't equal 0, y doesn't equal 0, x doesn't equal 0. What does that mean? Why is that there? Think about that for a bit. Also, another key point here to pay attention to is that r always has to be positive. And the reason for it down here is r is always equal to the square root. Well, square roots are only giving us positive values, because here when I square this number and square that number, whether they were negative or positive doesn't matter, because anything negative that's then squared becomes positive. Anything that's positive and then squared is positive. And then when you add numbers together, they're going to stay positive. So there's no way mathematically for r to be a negative value. And that's an important concept as well as we get further in this chapter, because when you're trying to figure out where negatives and positives are going, it's always good to keep in mind that r can't be negative. It only can be positive, because that like I said, that'll help you a lot. Okay, so what we're going to do now, for each of the following examples, we want to determine the values for x, y, and r. We want to find the given trig functions. So the terminal side of angle theta in standard position passes through the point -2, 3. Calculate sine, tangent, and cosecant. Okay, so before we freak out, because we have no idea what's going on, and that's a lot of math all at once, let's do the things we know. We're drawing coordinate planes, so let's draw an x and y axis here. Now, we've done this before. You've plotted points since Algebra 1. So let's plot the point -2, 3. So if we go back, -2, up 3, 1, 2, 3, we're going to have a point up there. So what this is saying is it's in standard position, meaning our angle starts here at 0. And then the terminal side passes through that point. So the terminal side is going through here. So this is the angle measure we're figuring out. Now, one of the positives to having x, y, and r definitions is that, well, this doesn't make a triangle at all. And that's kind of troublesome for our old way when you were trying to find sine, cosine, and tangent with opposite sides, adjacent sides, and hypotenuses. Well, this angle measure is not going to fit a triangle. So what we can do instead is we can use our x, y, and r definition, and we can find these trig functions that way, because we obviously can't draw a triangle, because that would be the goofiest looking right triangle on the planet. So we have an x value, we have a y value. How do we find r? Well, if you look back to the previous one, we're doing the Pythagorean theorem, where r was equal to the square root of -2 squared plus 3 squared. So that gives us square root of 4 plus 9, which is root 13. So now we have x, y, and we have an r. So now we can actually solve for our 3 trig functions. So for our 3 trig functions here, let's start with sine. So we need to put sine of theta equals, now hopefully we remember from previous that it's y over r. So y is 3, r is root 13. Now we want to be good little math students, so we have to rationalize the denominator, which means we don't want radicals on the bottom, because radicals are bad and they make math world angry. So we rationalize the denominator and we get 3 root 13 over 13. And that would be our answer. Now I want you guys to try tangent, and I want you to try cosecant, which is CSC. Try those on your own, and we'll go over your answers in class tomorrow. Alright, here's another one. Take a second, you may need to pause the video, write this down, and I want you to try this example on your own as well. Ooh, a challenge problem. Same thing as before. Take a second, jot this down. We'll go through all these answers in class, so if you have questions, at least you have them written down, and we can spend more time working on it. Alright, last part here, we're getting into quadratic functions. So we want to figure out how we could solve for angle measures that are on these axes. The nice thing is we're going to basically do it the same way that we just used, where you know your x and your y value. We're then going to plug it into the Pythagorean theorem to find r, and then we're going to come up with those answers. The nice thing is, since it's on an axis, you can pick any number you want. What I would do is I would pick some combinations of 1s and 0s. You can't use just 0 because that would put it there in the middle, which is not on an axis at all. So instead, you just pick a combination, like I said, of 1s and 0s. So I would use, every time we're going to use these points. So these are worth writing down. Alright, so that's going to conclude the video for today. We will continue the rest of the notes. There's not much left, so we'll continue those tomorrow.